This video is brought to you by Sporlan, quality, integrity, and tradition.
All right, this is an interesting one. Brand new equipment. I'm talking brand new walk-in, brand new coils. They got 3 new walk-ins at this restaurant. And they're saying this is their freezer, isn't keeping up. But that is a tiny, tiny coil. Compared to the produce walk-in that's about the same size, produce walk-in has a bigger coil. Now I haven't even ran the numbers yet, but something isn't right here. They're saying it's just maintaining like 6 degrees. So I'm gonna probe up down here and then we're gonna go upstairs and look at the equipment and then we're gonna measure out the box and do a load calculation. Okay, the coil is all frosted up, so we actually need to run it through a defrost, but I'm telling you, this coil is way too small for this box. It does have heaters, so it's an electronic defrost, but I'm gonna run it through a defrost and check it out. This is like a builder special here because that's the old defrost clock and that's the defrost clock that came with the equipment. It's still zip tied to the compressor. Like, what? Why? I guess I should stop asking dumb questions like why. I feel like those are irrelevant questions in today's day and age. Should just be, it's screwed up, you know? All right, 12:02, so the defrost time's not right. Let's go ahead and pump it down. There we go, we should be pumping down. Let's see what it cuts out at. What happens, that's one thing about probes, is it happens way too fast. So we were running at like 8 PSI. So the pressure control is set for about, cut out at about 5, cut in at about 15-ish. So, okay. It should be in defrost. Let's go down there, test the heaters, and see what's going on. Well, at least it shut the fans off, so hopefully they wired the defrost right. Okay, so that's the drain pan heater. It's got 1.4 amps. This is another heater, 1 amp. And there's one more heater right here. Okay, so all the defrost heaters are working, so that's a plus. We're gonna let it defrost and then hopefully evaluate it after that. All right, this thing is pretty defrosted, I think. Oh yeah. So let's go up top. Should have popped out on its own, but let's see how warm. It's probably about to pop out of defrost, but let's go ahead and go upstairs, eliminate the defrost, and then watch the unit operate without it being frosted up. My superheat is really high and it's not completely down to temp yet. It's about 10 degrees, I think, in the box. It's 109 outside, it's 13, but we shouldn't have 20 degrees superheat even at 13 degree air temp. So I'm gonna go ahead and make a little bit of an adjustment on the superheat stem, bring the stem down to bring the superheat down. Okay, if we wanted to raise the superheat, we'd move the stem up into the valve. So we're gonna bring the stem down, get the superheat just a little bit lower. I still wanna contact the manufacturer, whoever sized this equipment, and I don't think they sized it for the ambient temperatures because they've had this box for about 3 months and they said everything's been fine up until the last like 3 weeks when we've had just massive heat waves, and I don't think that it's sized right, so we'll see. When you make superheat adjustments, especially on these Emerson valves, you gotta give it some time. So I made a slight adjustment. We're gonna wait a little while, a couple cycles, and just watch it kind of drop a little bit as the box temp drops. We're still about 20 degrees above actual set point, so I don't want to adjust the superheat anymore, right? It's hovering right around 13 to 15, okay? So we adjusted it a little bit, but here's a problem. Discharge temp. We have a 240 degree discharge line right now. That's a problem. That compressor's overheating right now. We're not getting enough suction gas back to it. I'm telling you, I really think this evaporator is too small. So I reached out to the manufacturer to get me the BTU information on it, and I'm gonna reach out to the customer's person they purchased it from and see how they sized it. But it's 110 degrees outside right now, and we are just not getting enough cooling back. It's doing everything that it can at this time. Yeah, that's all I can do for the moment. So we'll update once we get some more information on it. We adjusted the superheat a little bit, but not going to adjust it anymore because we're still away from set point on the box. But here's an issue. Look at that discharge line temp. 240 degrees. At that point right there. 240 degree discharge line temp. That is way too high. This DTC valve should be opening, and I don't feel like it is. It is red hot coming out of this guy right here. Let's see if we've got an opening DTC valve. So we'll just use discharge temp, okay? So discharge temp says 120 degrees. Now let's look at the outlet of it. Yeah, that DTC valve, it's a cooling valve for the compressor, is not opening. That's a problem. That's a big problem. I wonder if that strainer's plugged up, or do we have a bad valve? That's the problem. So you do some percussive maintenance. I took a crescent wrench and started tapping on the valve. Watch this. Discharge temp coming out of the valve's now 71, and let's look at this right here. 111. So yeah, I tapped on it a little bit. It was like something was stuck in there. So that discharge temp was 240 degrees. Now it's dropping 232, 234. So we'll give it some time and see if it gets stuck again. There was something stuck in this valve. Probably not flowing nitrogen when they were brazing or something, who knows. It could just be a plugged up strainer too, it's hard to say. So that valve essentially senses the compressor head temperature, and it opens and feeds it. It's an expansion valve basically, liquid refrigerant, and it shoots it into the compression chamber and changes the discharge temp of the compressor, helps to cool the compressor's internals off basically. Someone else can probably explain it a lot better than I, but it's a thermostatic expansion valve, or temperature responsive expansion valve essentially. Seems to be working now. Discharge temp's still really high though, but it's slowly dropping. I still don't think this equipment is sized right. So, all right, well, this is all that I'm gonna do today. I'm gonna talk to the customer about replacing this valve. Should be under warranty, so they might want the warranty company to do it, I don't know. But we'll talk about replacing that valve. I don't know if there's something stuck in it or if it's just getting sticky, who knows. And yeah, that's pretty much it. We're gonna do the load calculation and see where that gets us. All right, I'm back because they said the box was down. It wasn't working. It says 25 degrees on the thermostat. Flip around, bam, iced up solid. So let's head up to the roof and have a look at that defrost clock. Come up to the roof and the equipment is not running, which is odd because it's calling. The defrost clock has the green light on, but it does not have the right time. It says 6 a.m. Now, the customer's not shutting this equipment off. I set this defrost clock when I was here the other day. So this defrost clock is definitely a problem. Let's go ahead and, before I do anything, we're gonna need to change it, and we're gonna install the defrost clock that came with it that was zip tied to the unit. But before I do that, I wanna find out why my condensing unit's not running. It could just be a low pressure issue. This unit has a time delay right here, and this time delay is preventing my compressor from coming on right now. All right, so if I turn this, it'll turn on. I just turned the time delay function off. And it's probably pumping down on low pressure because it's completely iced up, would be my guess. So let's go ahead and, because I don't know what the heck is like, so here's the thing. This customer called me, like corporate office, and they were like, we need you, we got a walk-in freezer down. Well, originally the customer called me, and then I emailed the corporate office. I was like, hey, that's brand new equipment. You guys should get the installing contractor, the installers back out there because it should be under warranty. Then they were like, we want you to do it, all this stuff. The problem is that I'm unpacking a bunch of stuff. Like, where do you start? Do I re-inspect the entire installation, which kind of seems like what I need to do, because I've already adjusted the expansion valve. I've already adjusted the low pressure control. We've already adjusted the door sensor because the door sensor was in the wrong spot. And the last time that you guys saw this video clip, I was here working on something else. I just happened to pop on the roof real quick. So I wasn't even really here for that. Like, it's just been a nightmare of stuff. So first, before I just swap out that defrost clock, I want to make sure that, like, it's wired right, you know, and they're using the right wires going to the coil and all that stuff. Like, that sounds like a mess. But I know for a fact that when I was here last time, I set the time on that defrost clock and it doesn't have the right time. So clearly it's a bad defrost clock. Came down here and it's running. So let me see, maybe it just terminated out or something. Wait, what the heck is going on? That's weird. It's been off on the roof for a few minutes. Huh, maybe like 10 minutes I've had it off. So I wonder what's going on here. I wonder if defrost termination's wonky or something. It's hard to say. All right, it seems like it's right. The wire color combinations, still something funky, but it could just be that that coil was a problem. I was like looking at this from me tapping on the valve the other day. That brass is really soft. I didn't even hit it that hard. I was just hitting it with a thing. I'm wondering if that's working too. I actually brought another DTC valve with me. Let's see if we have any more issues with it, because if so, I can change that out too. But yeah, I'm gonna swap this guy out and we're gonna use the one that was zip tied to the compressor that they should have installed in the first place. This plug also looks like it's barely making a connection. It was like barely even on there. That's odd. That would have been a problem too. Like, this is just a dumpster fire. Good grief. All right, I took the low pressure control, took the bracket off, mounted it on that back wall, put this guy right here, because I was gonna mount it using the bracket from the pressure control. You can do those sometimes, like on there, but this unit already has so little space for airflow to come out of this that I didn't want to crowd it anymore. So just move the low pressure control up, put that guy right there. We're all wired in. 1, 2, 3, please don't blow up. That's a plus. All right, now we need to go ahead and put it into defrost. So it's doing that because of it's trying to pump down right now. So I'm gonna turn this guy up, the time delay. And right now we should be in defrost. Yeah, we're in defrost. So we'll go make sure, I can see it, you guys probably can't, but we'll go make sure that we're pulling current on all the heaters. And then I'll come up here and start cleaning up my messes. And then we got to diagnose whether or not that DTC valve is still sticking or if it's been working good. We'll find out. All right, I had to go downstairs and I had to defrost the evaporator coil because it was just taking a little too long. So once I defrosted it, we're back and running. The box is at about 18 degrees. It was all the way up to like 30. So it's coming down in temp and I'm letting it run, and I'm actually watching this DTC valve open and close. So right now, this is my suction line temp is 111. That's actually my liquid line, sorry, 111. And when we clamp it right here, we're at 45. So this DTC valve is modulating now. So we have 242 discharge temp right here, and it actuates at like 250. So right when it gets to about the 240 range on the outlet of the compressor, that DTC valve is opening up. And I did pump the system down, pulled the stem out of here so that way it wouldn't actuate, and very quickly pulled the strainer from here. I couldn't show it on video. The strainer's crystal clear, so there's nothing stuck in the strainer. I just think originally the valve had something sticking in it a little bit. But so yeah, we are 100% working on that DTC valve now. I'm still kind of blown away that the discharge line temp is getting that hot, but it's high, you know? So over there, this is discharge right here, 241, that's the discharge line temp, that far away from the compressor. And then just again to confirm, I'm gonna take my liquid temperature clamp right here. This is liquid temperature, and liquid temp is 110 degrees. And then when we go on the outlet of this DTC valve, give it a second, and let's wait for it to open up. Oh, there we go, 65 degrees. So that DTC valve is doing what it's supposed to be doing. It's opening and closing based on a 250 degree head temperature on that compressor. Then it's opening the valve, throttling as the temperature raises. So if we pull that head out of there, it'll shut off. What is a little concerning though is that there's no thermal paste inside of that. And the new DTC valves, they come with a little thing of thermal paste. It looks like you got a little heroin needle. It's kind of crazy. I'll show you guys some point in this clip or this video.
So look at, with every DTC valve, you get a nice syringe full of heatsink compound that doesn't look like heatsink compound. Like, what the heck? Think they could have come up with some better packaging for that?
But yeah, they're kind of crazy, but this thing is working. I did do some research. The equipment is technically sized right. It is literally perfectly sized with no wiggle room. It is at the edge of the capacity of this equipment. As the equipment hits 110 degrees, the BTUs fall off the map from the condenser. And then as that DTC valve opens up, it also reduces the capacity of the system slightly, not a lot. I don't have any numbers to show it, but I mean, just common sense tells you. But yeah, this equipment is sized right. It is just marginal, and it had a bunch of problems. I really, really recommend that they still go up a size on the equipment. The internal volume of that box is so small. Their kitchen temperature is maintained at 76. Their thermostats are like right at 76. It's really more or less 80 right by that walk-in door. And then they have a giant oil tank right there that heats up the oil. That's slowly warming up the outside of that box too. It's not like crazy, but yeah, that's a problem. And so this is a 2 horsepower condensing unit with a, I think it's a 6500 BTU evaporator coil with 448A. Or I think the balanced capacity is like 6,500 BTUs, and I think the required capacity is like 6,000 or something. It is right there. I really, really think they should have sized it up a little bit more. And I realize for energy efficiency and stuff, you want to size things properly, but this is a customer that has high volume. They don't do really good at closing doors. They use that box constantly, opening and closing the door on the hot days, and that temperature just rises. Now, the problems that they had and the problems that we fixed, the evaporator superheat was never set correctly, so we adjusted that down. That's going to help with our discharge temps. We also, and that's going to help with the efficiency of the system. I also cut back the suction line insulation to the compressor. If you leave that insulation butt up against the compressor, it'll start to rust out the compressor over time. So I usually cut it back about 6 inches. We installed a defrost clock because their defrost clock wasn't working right, and we adjusted the pressure control because the pressure control wasn't working right. Now there's another flaw in this, in that there should be a check valve in between on this suction line, in between the compressor and the low pressure control. What can happen on this is the system will shut off. Then see, if you look right here, the manufacturer is pushing this past the compressor manufacturer's operating envelope. Copeland doesn't want cut out at 3 psi on these compressors with a differential of 12. They don't want it. They want cut out a lot higher than that. But you got to set it there to get the box temp that you need. And the problem with that, with the way that they size the equipment and stuff, and the problem with that is when it shuts off, there'll be an internal pressure relief, and the suction pressure will jump, and then it short cycles on, off, on, off, on, off. Now, one thing that the manufacturer did to combat that was they put in a time delay relay right there. So it basically, even though it says to turn back on, it won't turn on because the time delay relay is holding it out. But in reality, they should have a suction check valve right here and then have the pressure control on the other side of the check valve. So that way when it shuts off, the refrigerant coming back from the internals in the compressor when the pressure relief happens, I believe it's through the floating seal, I think. When the pressure relief happens, it won't turn back on because the check valve won't let the gas come this way. It will only let the gas go that way. That's something that they should be doing. They're not, whatever reason. And but yeah, that DTC valve is still working. We got 60-degree outlet on that DTC valve. So, oh, and the other thing I did was I moved the temperature device right here a little bit further away from the compressor. Not far, but a little bit further. So yeah, that's all we're gonna do on this one. We're gonna tell the customer to keep an eye on it. All right, it's cooling. It's 9 degrees in the box right now. These thermometers are junk, but it's being accurate. It's frosty a little bit. They need to keep the door shut. I'm gonna talk to them about upsizing this. This is right at the border, like I said, but that's it for now. So when we first got this service call on this walk-in not working, I immediately, like I kind of mentioned in the video, reached out and said, hey, that equipment is only 3 months old. You need to contact the manufacturer, the person that installed it. You should have all kinds of warranties, right? And the customer was like, the corporate office was pushing back, and they're like, you're our guy. We want you to go do it. And I said, okay, but I don't want to deal with warranty. Like, I've got too much stuff going on right now. I'm not going to deal with the hassle of the warranty, especially for equipment that I didn't install. But to be careful, I wouldn't have installed a walk-in box. I don't do walk-in boxes. I'll install the equipment all day long, right? But I also, it would have been great if they would have used me, because it would have been back in March, April, somewhere in there is when they got it installed, and I would have had time. Right now in the middle of the summer, I don't have time to unravel a disaster of epic proportions like this, right? And I already spent way too much time on it. The first clip that you guys saw me there, I was there working on an ice machine. I just jumped over to it real quick, and I was like overwhelmed. The second clip, I spent a little bit more time going out there, correcting the issues. But overall, the pressure control was never set right. The time clock was never installed. They used the old one, which wasn't keeping time. The, what else was it? The pressure control wasn't set right. The time clock wasn't set right. Something else too. I'm brain fart right now, but I mentioned it in the videos. You guys already know. But it was just like an epic cluster, Oh, superheat was never set for the expansion valve. It was way too high. It really leads me to start questioning. Here's the thing. I'm super slammed right now, right? So do I go over? I still haven't inspected what size lines they used. I mean, you never know with an install like this. It looks okay. It's 5/8 on the roof. It's 5/8 downstairs. But I didn't even do the math. Like, is that the right line size for a 6500 BTU evaporator coil, which is what they say it delivers with 448A, right? Because of the glide and all that stuff, which I don't know. It's kind of frustrating, right? And I know I should be thankful that these customers are calling me. It's great. It is. But there's times that it gets to be a little silly, right? It gets to be kind of frustrating, and there's more that I want to say, but I got to be careful because there's probably a lot of eyes on this video. So I need to be cautious about what I'm saying and stuff. But I just think overall, some people dropped the ball. They didn't take into consideration that this is a high volume restaurant with a low volume box, meaning that the box is really small. It's 8x8x9, okay, or it's close to that, right? And it has a giant door. They're maintaining the kitchen at 76 to 80 degrees right in there. It's right at the end of the cook's line. There's fryers right there. They've got a giant oil tank that's heating up the oil literally 2 inches from the door up against the box, adding heat load to that box. And every time they open that door, the temperature inside the box, because of the low internal volume, jumps so high, and then it takes a long time to recover. Like, they just really didn't think this one through. The box itself is fine. The equipment is fine. It's just not sized right, in my opinion. They should have gone with the next size up, gone heavy duty on this load. Now, I realize when you go heavy duty, the problem that you oversize the equipment technically, right? So that way it can maintain at the hottest parts of the summer. Well, in the wintertime, because it's not variable capacity equipment, then you start having issues because your evaporator TD goes through the roof and becomes a problem. There's lots of downsides to this, but unfortunately, when you're in the desert-ish climates, this is in Riverside County, but when you're in the desert-ish climates, this is just the kind of stuff you got to deal with. We have, it was 110 degrees on the roof that first clip, right? That's not the hottest it's going to get there. It's probably going to get 115 to 120 on that roof. It doesn't mean that it's 120 ambient outside, but it's on a roof with high parapet walls where they don't, they have a white roof. It's reflecting off the roof. The temps are just ridiculous. And the delivered capacity of that condensing unit falls off the map once it starts to go above 100 degrees. And, and it's just, there just wasn't a lot of thought put into this equipment, and they really should have thought a little bit harder about it, and maybe upsized a little bit to compensate for that. It's just kind of a bummer. And it's frustrating, though, too, because, again, I'm busy, and then I get thrown this in my lap, and it's like, I really want to go through that entire install with a fine-tooth comb. I want to inspect every inch of that line set to see if there's kinks in it. Like, I want to go through everything, but I don't have time to do that right now. And again, I know it may come across as I'm complaining. I mean, I guess in a way I am, right? But I'm venting to you guys. You guys are hearing my frustrations.
do as I say, not as I do kind of a thing, right? You know, be courteous to the customer, be thankful for the work. And I am in a way, but it's also frustrating at times too, especially, you know, with the stuff I've been going through lately with work and just chaos. And it is what it is, right? So at this point, I've told the customer that they need to consider upsizing this equipment, right? To compensate for the added heat load, to compensate for how many times they go in and out of this box, multiple times an hour. Multiple. If I had to guess, it's at least 8 times an hour is this door open for the cooks to go in there and get a single box, because they don't have room for a stand-up freezer in their cooks line. They just have some drawers that they keep some product in. But so they have to go back and forth to this box all day long. And again, with that low internal volume of that, the temp just flies through the roof every time they open that door. And it's just really wasn't thought out very well. But who am I? Just some silly refrigeration contractor who kind of knows what he's doing, right? I'm not like the best in the world or anything. So who knows if they're going to listen to me. And I don't know if I mentioned it in the video or not too, but I also found that one of their other walk-ins, I call it a hybrid freezer because they maintain about 26 to 28 degrees inside the box. Yeah, they put an air defrost evaporator coil in it, 115 volt air defrost evaporator. And the customer's wondering why they can't get it cold enough in that box, because I can't set it any colder. I'm surprised it hasn't iced up being set at 70 or 32 already. And it's just like they did not think this one through. So someone needs to come in and correct all these issues. And I'm really trying to get the customer to have the original installing contractor and the manufacturer, whoever sold them, the distributor, correct this and make it right. And preferably, it's not my problem in the next couple weeks because I'm busy. You know, I don't have time to go redo all their walk-in equipment, change line sets and all that stuff. You know, there's a time and a place for that. October through April, all day long. I'll change equipment and stuff like that. You know, I don't mind changing equipment for a customer in an emergency situation in the middle of the summer, but I prefer not to. But I mean, if you got to do what you got to do to keep the customer going, go for it. But in this situation, it's kind of frustrating because you know, having to solve these problems when I wasn't even part of the original design or install. Yeah, kind of frustrating. But hey, you know what? Maybe I'm just being a whiner. Let me know in the comments. I really appreciate you making it to the end of the video. Hopefully the video kind of made sense to you. This is just a day in my life. Like, this stuff happens all the time, like genuinely. I don't ever get to get it on films most of the time, but you know, this is just one of those frustrating moments. Again, I really appreciate you making it to the end. If you haven't already, please consider subscribing to my YouTube channel. HVACRvideos.com is my website address. Check it out. We got merchandise available on there. You can support the channel via PayPal, Patreon, YouTube channel memberships, but those are all monthly commitments that you donate whatever you want financially. You don't have to do that. You know, the easiest way to support this channel is literally watch the videos from beginning to end. That really is the easiest way. If you see any tools like the JobLink probes that I was using in this video, you can find them at TrueTechTools.com, which is a HVACR tool website. I have an affiliate program set up with them, so if you see anything you like, you can use my affiliate code, big picture, one word, right? If you put that in at checkout, on majority of the items on their website, you'll get an 8% discount at checkout, and then I get a small commission. So that's another great way to help support the channel. Again, thank you so very much. Leave me some feedback down in the comments. Let me know what you think. I really appreciate you, and we will catch you on the next one.